Good morning, everyone. My name's Billy. I'll be the speaker chair for this speaker stream. So it is my pleasure to bring onto the stage Mike for his talk on endpoint detection. We won't have any time for questions just because we're a little bit short, but feel free to submit them in the app and they can be answered by Mike at the end. Thanks.
Thank you. Hi, everyone. I'm Mike, and I will talk to you today about improving detection efficiency on the endpoint. And really, what I'm going to talk to you about is event tracing for Windows as a way of improving detection. And it's unfortunately not a magic bullet, and it's not a final solution for the problem of detection. Because detection is really an evolving field. So I'm going to show you some of the problems with detection and how how it evolves. So detection engineering is really all about finding specific patterns of activity on the endpoint that indicate malicious activity. So if we have an endpoint and we're monitoring that endpoint for malicious activity, detection is all about how do we detect that malicious activity happening. So in this talk, I'm not going to focus on a vendor or tool. It's like a general, I'm actually going to focus on Windows with ETW, right, more than anything. But it's really about ETW, and ETW is used by many, many vendors now because it is a really good tool for that. So it's kind of like vendor neutral. So what is happening in the state of detection right now, the state of the art, or the commonly, implemented methods. So normally what a lot of the products do, we have event logs generated on the endpoint, and then somehow the event logs are being forwarded across the network to a central storage like a SIEM and with a data mining, usually a data mining type engine. And then there are some queries run on the data mining engine to detect malicious activity, right? So this is kind of like the state of the art, or the normal sort of products. So what actually happens with this model is that the event logs are just kind of like getting sucked into the network. Typically, for example, like let's take Sysmon as an example, but Sysmon is a very common event log source. So a lot of people use it. Sysmon is running on the endpoint, and it generates logs for various things that happen, like process creation, DNS lookups, various things. And it's a really good tool made by Sysinternals, which is part of Microsoft now. And anyway, it writes the event logs to the system, and then some kind of agent software forwards those logs on. I'm just taking an example here, the Elastic Stack. So it uses WinLog beats, and it forwards it on to it transforms the fields around to data massage it a little bit, and then it sends it off to some big database, in the cloud usually. And then there are some analysts are querying this information. So that's like a general architectural diagram. And we have a whole bunch of work around how do we detect malicious activity based on these logs that we get, right? So, for example, Sigma is a very popular interchange format notation for conveying these ideas of, what is actually malicious activity in all these logs that we're seeing. So we're looking at all different process execution, what is suspicious, escalation and that sort of thing. So Sigma particularly is written, so it's kind of like a generic detection format language, I guess, to write rules. And then those rules can apply on many different types of backends like Splunk or Elastic or other types as well. And you can see, here's an example of a particular detection, and it would say something like, looking at process creation events, and if ps-exec is run, that's suspicious, right? Obviously, it depends on the environment. Some people use it for administration, but that rule will fire. So whether that rule is appropriate for the environment, it's up to you to decide. But that is generally how the rules work. Now, generally, most of the Sigma rules, because they operate on the data mining side, they assume an event log source, usually Sigma, basically, usually Sysmon, sorry. So Sysmon is very common for process start events. Not the only source, but in this case, it's assuming process creation events. So generally, Sigma detections are pretty weak because what they do is they just kind of look at things that they have. So in the example that I had here, it's saying the command line is psexec. Well, the command line doesn't have to be psexec. It can be anything. You can just rename the file to whatever you want, right? So it's a pretty weak rule because it matches file names, and file names can easily be changed by attackers, right? So these types of rules are pretty easy to defeat and not very robust. And the reason why is because ultimately the reason why that happens is because they can't really figure out more information than what they're given. At the end of the day, all you're given is a process execution event. And Sysmon says, hey, this process ran, that was the name of it, or the name of the binary, and so on. And that's all you've got to work on. So it's not really a limitation in Sigma itself, because Sigma just has, you know, the data that it has to work with. It's just a limitation in the richness and correctness of the data that it's getting. So this is kind of the takeaway from these slides, is that it's not really the technology that's at fault. It's just that it's limited by, you know, what's available. So here's an example of a report, the FIR report, where threat actors are changing the name of the psexec service. It's just a command line option. They just give it -r, and it creates a different name service. And they're doing that primarily to avoid these kind of Sigma rule detections, which rely on file names, right? So we need to use some other information to be robust against these kind of manipulations, because as you can see, attackers are, you know, exploiting that. So let's look at what kind of data we can get from Windows. And Sysmon is an excellent source, so that's great. But there's actually quite a lot of other sources of data that Windows can generate for us. So it can generate a large number of logs, right? So we can just start forwarding more and more types of logs, right? So if we forwarded Sysmon, we can forward, you know, process start, we can forward, you know, RDP client logs, RDP server logs, mail logs, the list goes on. But of course, the problem with forwarding it in the previous architecture that I showed is that the more logs that we are forwarding, of course, the more data we are pumping out to the cloud, the more data we need to sort through. And also, a lot of the logs that would be useful for security, they're not actually specifically geared towards security, so they actually have a lot of events. You know, the log files have lots of different events. So we might need to kind of like say, well, we need these kind of events, but all of these ones are not relevant for security, so we don't care about forwarding them. Then it becomes a question of like trying to pre-filter which event types we want and so forth. So here's an example of, I've just got an example here from the event viewer of an event that would be super useful to know. For example, terminal services, remote connection operational, tells us when someone logged into the box with RDP, right? That's really useful from a security perspective. And a lot of people forward that one, as well as the Sysmon one that I have, you know, opened up the top there as well. So now we're adding more additional types of logs. So Sysmon, I just want to say a few things about Sysmon. Really good. It has lots of types of events, process execution, driver loading, DNS, and so on. It also does some really cool stuff. Not only does it show you process execution, but now it actually looks in the binary itself to tell you things like the original binary name that is stored in the P header of the binary. So if people are leaving off the land binaries and just renaming them, you know, like we've seen before, that doesn't matter. Sysmon will still see that because the original binary name will actually come through in the event. So this is really cool. They're enriching not only just in the information of process execution, they're enriching that with other types of information that they're getting from the endpoint. In this example, getting from the P header the original binary name and signatures and other things like that. So these are all really, really good. And in fact, that sigma rule that I showed before, if we change that, instead of saying command line has PsExec, if we said something like original binary name has PsExec, that rule becomes much harder because it's harder to subvert, because as long as they're using the same binary, just renaming that is not going to, it's not going to confuse the rule because it's looking at the actual binary. So that's kind of the takeaway from this slide, is that by enriching these processes, these sources of information with other information that can be found in the system, then we get a much better quality signal. Sysmon is an excellent example. So here's an example of a Sysmon event, and you can see the original file name is cmd.exe, right? And you can see that the parent file name, parent command line is psexec, SVC, that's the service that started by psexec, and you can build a detection around that to say, hey, psexec is running command shell. That is really bad. I need to look at that, right? So that's already, we can start to write some pretty good rules based on the original file name. That's excellent. So that's really cool. But we want to get better, right? So Sysmon is a good step in the right direction. How do we get better than that? And I'd like to talk to you about event tracing for Windows, because this is really the underlying mechanism that is used in Windows to manage logging of all kinds, right? So it's really like a fundamental part of the operating system. And I just wanted to introduce you to it. You might already know all about it, but I just wanted to talk about that today. Now, the ETW is actually the underlying mechanism that is enabling that event logs to be collected in Windows, right? And it's a really smart system. It's really clever. The idea of ETW, you might imagine that all sorts of software might want to log stuff all the time. But if you allow everything to log everything all the time, system would get really slow, right? Because there's just a lot of logging going on, right? So ETW is a really clever way of mediating that, of enabling some logs and disabling other logs based on how the administrator set it up. So the concept of ETW is that we have a provider. So that's a type of software that would like to generate logs, right? So, based on whatever logs, right? So pretty much many softwares, if not all softwares, have a logging functionality of some sort, right? So there'll be a provider. And then we have a consumer. So the consumer is someone who's interested in listening to these events, right? And then ETW marries the providers with the consumers, right? So that's really the key. If there is no consumer that cares about a provider, nothing happens, free, right? There's no logging going on. So there's no performance penalty at all, right? But so we can essentially, by consuming different providers, we are making the provider generate those logs. They're not generating them otherwise, right? So we are just turning it on and starting to get those event feeds. So this is a really clever system where we can balance visibility with performance, right? Because they're kind of competing in some situations. The more we log, the less performance we have. So this is a really great idea. And it's the kernel and the operating system is really kind of like driving all of this. And in order to listen to a provider, we have something called a session. And a session is just like a thing that tells the system that now it starts to record, and there's buffering and other things, but I'm not going to go into these details of that. But in principle, that is kind of the idea. So the way it works is that the providers advertise that they are able to provide using a GUID, which is a unique identifier. And then all the consumers say, okay, I'm going to listen to that, I'm going to listen to that, I'm going to listen to that. So that's really all it is. Let's have a look at some example. So you can actually ask the ETW system to tell you all the providers that are registered with the system, right? You can run this command, logman query providers, and it just tells you all the different kinds of providers. So it's worth just having a quick look, and you can see that there's actually a lot of providers here. I just took a screenshot of the top few, and you have a name, the name of the provider, and you can see like Active Directory, like, and it goes on. And then the GUID is the unique identifier that identifies this provider. So we are not really using names, we're using these GUIDs. But the GUID is unique for that software, for that piece of software. Now, what providers are available, right? So there's been some efforts to try and document that, because it's something that we need to kind of discover, because, providers can come from Windows and can come from third-party software as well. So there are some, GitHub projects trying to document it and trying to understand exactly what events are actually generated and what we can listen to. So there is this, this is actually a link in the slides you can check later. There's a project that just kind of like collects these XML files that tell you. So it's kind of nice to sort of discover what's available and try and look and see how we can use some of these for detection, right? So I'm going to demonstrate how you can actually do this ETW thing using an open source endpoint visibility tool called Velociraptor, but that is not just the only tool that does it, of course. It's just ETW is a generic method, so a lot of tools use it. Velociraptor is kind of neat though, because it has something called VQL, which is the Velociraptor query language, so we can enrich those events, right, as well as just forward them, so we have more control over it. And then finally, I have a link here for something called Web Explorer, which is a tool I just discovered recently, which is a GUI tool that allows you to get that information that I showed you before in the XML, but in a much more user-friendly way. So I quite like it. I've got a screenshot here of kind of what it looks like. And so you kind of like search the GUI, you can choose the GUIDs, but you can search the names up the top. It's kind of hard to read, so I've got an inset to kind of blow it up. So in this case, I'm looking for anything that has to do with DNS, and it's showing me a couple of providers, DNS client and Diactrack. And then down here in this window on the bottom, it shows me the type of events that can be generated from this, ETW source. And so I can see, and I've got here another inset to just make the font a little bit bigger. This one is telling me when a query responds for a name. So in other words, that is the source that's telling me when a response comes in. And I can use that for detection because I can say, hey, if someone's doing DNS queries, it might be a beacon or it might be some kind of, malware. So if I just look at that event specifically and just record DNS, that allows me to just essentially stream all the DNS queries, which is really useful for detection. So how do you do that? I've just got a screenshot of Velociraptor here, and I'm just showing you, because it has a query language, it's pretty straightforward. I'm just watching that GUID, which is that GUID I found before, and I'm only looking for that event ID that I showed you before in that screenshot. And it's basically telling me, this on the left, I've got, so the way that event logs work in Windows is that there is a common system kind of structure, which is always the same for all the events. So that's the system part. And then each event has, specific data for this event. So, in this case, it's saying, okay, there was a DNS query for google.com and that came back. That's the answer. So it's good for logging. And I can use Velociraptor to just collect that, right? And just stream that from all the endpoints and then collect all the DNS queries, and then I can use that to, look for CNC or whatever, right? So I can use that for enhanced detection. So that's really great. The next thing I wanted to show you, though, is something that is more than ETW, right? So we'll go back to our event log that I showed you before, and many people don't know this, but you can disable event logs very simply. What you do is you go to the event viewer, you right-click on the log, and click Disable Log, right? That's not very hard. So if you have a system that forwards event logs, now it's gone blind, right? Because just disable the logs, right? So how does that work? How do we just disable the logs? Well, it turns out that, as I said before, ETW is the mechanism that drives event collections, right? So the event viewer and the event service actually is really doing an ETW. It's really listening to the events with ETW, and what that does is it just enables and disables the providers in the session, right? So we can just disable it, and then we don't get any more logs from there, right? So we can just turn it off. So it turns out that when you click that button, something happens in the registry, changes some keys, and it disables it, right? So we would like to know if someone disabled it, right? Like that would be kind of important, right? If someone disables, because that's a signal, right? It means that like somebody's messing with the system, right? So, but in this case, we need an additional source of information, right? because obviously apart from the fact that if someone disables syslog, sysmon logging, then we actually can't receive any registry change events anymore, like because the logging is disabled. But we need to know something from the registry now. So there's another source of information that we need to look from. All right. So it turns out that in Velociraptor we can look at registry keys and particular settings of registry keys. And so we can do things like hunt across a whole bunch of systems and say, okay, which systems have this event log enabled, which systems have this event log disabled. And this is just a slide from the workshop we did earlier, where we basically just did a stacking exercise where we went through and counted all the systems that had bits client was disabled, that enables equals 0. And there was only one, and most of the systems had it enabled. So you can tell that using this method that somebody's something's odd going on here. Or you can use Sysmon to monitor registry changes as well, right? So you can say, hey, in Sysmon config, if anyone changes these keys, I want to know about it, generate an event. But of course, then you have the problem of like, how do you know about this if the event log's disabled? Because it's kind of goes through the event log, right? So it's going to be a bit hard. But the interesting thing about this is that ETW is not really affected by those settings in particular, right? Because it has nothing to do with the event log service, right? Because the event log service is sitting on top of ETW, and you can disable that all you want. But if we actually forward the Sysmon events through ETW, then we have it's nothing to do with the event log service. We don't even need to have it enabled. It doesn't matter, right? We're just going underneath the event log. So we still do see those events. We'll see the PS exec happening, right? So that's kind of interesting. So that's a plus to ETW, right? That's great, right? Next, I'm going to show you some examples where ETW is the only source of information that we can get, right? So types of data that really are important. And the thing that I wanted to show you in this example is parent-child relationships. And create process API is something that Windows uses to create new processes. And usually, when a process calls another process, then we have a parent-child relationship. And a lot of detections are written around like these parent-child relationships. Like if this process, like if WinWord starts to run PowerShell, well, that's pretty bad, right? Like something's happening that shouldn't be happening, right? So there's a lot of detection written around these process-child relationships. But I don't know if you guys know, but in Windows, parent-child relationships are very easy to defeat, very easy to spoof, right? And it comes from the design of the API, and maybe because it was designed, in the 90s or whatever. But it's actually pretty easy to defeat this. And I just wanted to show you on the right how I have a blog post that explains it, so you can read that as well. But there is a tool called Select My Parent that helps you test this, just like a little test tool that like you can play with. And I just wanted to point out the date of when the tool was launched, 2009. So it's been around for a long time. And this ability to fake parent-child relationship has been around for a really long time. It's basically built into the operating system, which is surprising. I was surprised about it because it's kind of weird. And here's an example of me using the Select My Parent tool to attach Notepad to Sysmon. So you can see what happens in the administrative command prompt here. I'm running Notepad, and I'm saying run Notepad and select the parent of the process ID of Sysmon. So now, on the right hand, in there, I've got a process hacker, which shows me like a tree, process tree, and it will say, oh yeah, Notepad is sitting under Sysmon. So it looks like Sysmon launched Notepad. Now, Sysmon doesn't launch any processes as far as I know, so it's a bit weird. But if you have a security tool, right, that can run PowerShell or whatever, like as part of its function, then if you get a parent-child relationship like this, a lot of people give security tools a lot of leeway, like, oh, they're running encoded PowerShell, but maybe that's okay because, it's a security tool. So it means that it's actually quite difficult to tell that it's malicious because people attach trust to this parent-child relationship, right? But it turns out it's very easy to do this. So if we had Sysmon forwarding events, can we detect this? Can we detect this behavior? It turns out no. Sysmon totally says the same thing, right? It says, yeah, look, sysmon.exe launch notepad.exe. So Sysmon is not able to see that it's been spoofed at all, right? It just goes by, this thing. So it turns out that it's actually this parent process spoofing is pretty low level in the operating system. So a lot of detection points can't really see that. It turns out, this is what I mentioned before about it causes problems down the stream of the SOC because you can miss things, and also, certain things are obviously bad and certain things are not so bad. And, our attack is using this. Absolutely. Here is a training video. It's on YouTube. You can check it out for Cobalt Strike, which is the most popular attack tool out there, as far as I'm aware. And in that video, they're explaining how we can launch, an attack, and just apparently this parent process spoofing is a built-in feature in Cobalt Strike, so they use it all the time. And this is how they're doing it. You can see that in this video, they are attaching the PowerShell to Explorer.exe instead of to the malware, so the analysts in the SOC can't see that it's coming from the malware. So people are using it, they've been using it for years, it's been around for years, and we still have poor detection for this thing. So it turns out the only way that you can tell, that as far as I know, and I'm happy to be corrected, let me know later, but the only way that we can tell that this spoofing is going on is with an ETW source, which is the Windows kernel process provider. And it's really an indirect way, because what happens in this provider is that it's actually generating an ETW event that says this is the parent and this is the child, but the event itself is coming from a different process, which is very abnormal, because normally the process that calls create process is really the parent, so it should match most of the time. But in this case, it is not matching, and the fact that they don't match indicates that there's a process injection going on. So over here, this is our artifact exchange in Velociraptor. We have a detection written for it, and I just wanted to, this is the VQL, I'm not going to go into too much detail, but after the where keyword, you can see that this is the detection. We're saying where system.id is one which is a process creation event, and the process ID, the system process ID, is not equal to the event data process ID. So in other words, these two fields are not equal. If they're not equal, that's a detection, right? So this is what we are warning about. And so you can see that very clearly once we install this event monitoring. We can see very clearly that Select My Parent has launched OneDrive, Notepad under OneDrive, for example. And so you can see that when you run this detection, you realize there's actually a lot of this stuff going on. For example, UAC elevation works that way. So it looks like it's process spoofing seems to be a built-in part of the OS, because some parts of the OS actually use it. So you can whitelist these legitimate uses of it. So ETW is awesome, right? So ETW is awesome, right? It's wonderful. How can we're going to use this? Well, not so fast. It turns out that there are actually quite a lot of limitations in ETW. So depending on because the ETW is generated in the running software, so if it's an ETW source that depends on user space code, then it may be possible to disable that. And so if we rely too much on it, that could be a problem. And also the other limitation is that ETW uses these sessions. Now over here I've got a slide from an article about defeating and bypassing ETW solutions. And over here we have all the different kinds of attack paths. It's a really great article. I encourage you to read it, of actually defeating ETW. I mean, and some of them are pretty straightforward. The simplest one that I know is simply resource exhaustion. It turns out that ETW can only support 64 sessions. So all you have to do is just open 64 sessions, and then you can't attach to ETW anymore, right? So you're breaking a core system functionality. You don't even need permissions for that. You can see all the different sessions on the system. This is an artifact, a Velociraptor artifact that you can use to collect it. And you can see some interesting ones here. So for example, I have Sysmon running, and I can see a couple of Sysmon-related ETW sessions. Turns out that Sysmon also monitors for DNS in much the same way as I showed before, and it uses the Sysmon DNS ETW session. Turns out, so this is the same thing using the query ETS. It turns out that I can just turn off the ETW source, right? So here in this example, I just go logman stop, I turn it off, access denied, I become system, and then just turn it off. And that's all right, and that works. So I can actually turn off Sysmon at the ETW level as well, but just killing the ETW session that is listening. This is the event log monitoring session. And similarly, all kinds of similar thing. I can kill the DNS one and so on. And Sysmon doesn't actually realize that the session's terminated. So so if you just kill the DNS, so it gets DNS events through the ETW. If you kill ETW, then it will continue running happily. Just you won't get any DNS events, right? So you won't even realize something's wrong. All right. So over here, yeah. So as I said, it's easier to do it with ETW. The other thing is that ETW can be abused by malware, because you can understand that knowing when something's happening on the system is actually kind of useful for attackers as well, right? So an attacker can use ETW for malicious purposes like keylog strokes and so on. This is an example of a keylog-based ETW keylogger. It turns out that ETW has a metadata ETW source. So in other words, a source in ETW that tells you about ETW itself, right? Which is really cool because it enables us to look for changes in ETW. So for example, we can tell when new sessions are installed and when new sessions are deleted as well. So this is really important for, in this case, Sysmon with the DNS ETW source. If someone goes and kills it, like I showed before, this will generate an event like, hey, ETW state changed. So this session was terminated. So we can actually try and look at that. So we can check for presence of ETW sessions and look for detections based on that. Because, you know, if Sysmon's running, we expect the DNS one to be running, right? And so on. And then ensure that there are enough available ETW. As I said, there's a limit. And so on. So in conclusion, ETW is a really powerful framework. It's really powerful, and a lot of people are using it now because it gives you visibility into a lot of states that you don't have otherwise. And we rely on it heavily, right? But it's not a magic bullet. There are still problems with it. It's not really designed for security, so it's not super robust. And it's important to understand the limitations of ETW when we use it and evaluate it. But it's really great. It does enhance the detection visibility. And sometimes we can use changes in ETW, like anti-forensic attacks against ETW, as detections. If we are able to detect them, then, you know, it turns out that, you know, we are using them as a detection. And finally, if you wanted to have a play with that, and the slides are actually also available on our docs site here, and you can check out Velociraptor. It's an open source endpoint visibility tool with, you know, all these capabilities. You can go through the exercises I talked about today. And if you have any questions, because we don't have question time today, then we are always on Discord as well. And we'll be around, Matt and I will be around in a conference, and would love to have a chat with you guys. So thank you very much. Thank you. Thank you.
I'd just like to thank Mike for that presentation, just with a speaker gift.
Thank you so much.
We did have one question, and that was whether or not the speaker slides were going to be available, and they are available on the...
So this is our documentation site, as I mentioned, and you just go to presentation, also 2022, velociraptor.com.
Perfect. Thank you very much.
Thank you.
Give it up for Mike. We'll be back in 5 minutes with the next presentation.